with solar is it gives you energy when the sun's shining, basically. You'll set up an array. You'll find your site. You'll set up an array. You have your panels. Um, they gather the photons, turn it into a DC current, send it down the line. When you're getting your solar system, you're not just getting panels. What you have to deal with is about 5 different components. You have to have your racking or your placement. Most of the racking these days is made to warranty longer than a roof. So you'll probably want to do a ground mount systems. So you have to get all your racking, your assembly, your wiring, and most people are running. The reason solar PV is actually commercially viable these days is the Italians in 2003 came out with an inverter that would match the sine wave from the power grid and feed that into your house off of the DC current. You can do standalone systems. Are definitely a very integral part of standalone systems. The problem is if you use a battery system, you lose 30% of the electricity from the sun. As soon as it goes in your battery banks to pull it back out, minus a third. So you're looking at not getting the juice back. Most storage systems don't have high amperage. So if your major appliances, your microwaves, if you have an electric oven. Now, if you have a geothermal system, other than their startup voltage needs, those can actually pretty much be maintained by a solar system. They've been integrating panels in with heat exchangers so you can do your house conditioning with a standalone system off of your array. But the main thing is when you go to get a solar system, you're buying like 12 to 18 years of electricity up front. Your panels technically will produce for 50, and there's no moving parts in it. Now, if you go for your own standalone system to where you're not relying on the grid at all, there's a lot more that has to be taken into effect. Your startup amperages on everything. You have to basically recondition your home for what your energy produces. The grid tie inverters, what they do basically is they'll shut a system off from the grid as soon as the grid doesn't do power. They had to do that for the power line people because if there's a power outage and you're shooting, your household usage back up at the pole, as soon as it hits that pole and the coil and goes down the wire, it's back up to 70,000 volts. So it's like a big health issue. So you can do a Sunny Island system. There you're looking at, if you go for your own battery banks and your own island, it's probably about a third of the more cost to implement it. Now, one thing that they've started to do, they have in California in some districts, it's really big in New Hampshire, they have the smart grid systems, where you can get an inverter and your battery bank actually helps take the unsync out of the line. It'll stop, areas from brownouting so much because you'll have your current and your voltage not matching up at all. I don't know if you guys have studied, sine waves. But so if you get a standalone system, my thought in personally integrating it in is to go with the smart grid system with the battery bank, because then the electric company providers have to pay you for the juice, basically, at a better price. And once they have 10 systems set up in an area, that's when you can reap back the cash benefits. The main thing is it's environmentally friendly, and you don't have to maintain it at all if you don't have a battery bank. You put it in there, it hits the inverter, it goes down the line. There's no pollution, there's no real big carbon footprint. They are made out of silicon. One thing I didn't know before I actually started studying it is solar panels work best when they're cool. So just like any electronic component, they work better when they're not so hot. So you can put an array up out here with some similar panels that someone would put up in Arizona, and even though they're getting sunlight for 2 to 3 more hours at the right angle for your array, the most solar panels have a 15-degree window, and so you'll get like 3 to 8 hours of sunlight depending on the time of year on them. But they've moved it up to where they do laminates. I'm sure you've all seen like the little boards, but they've moved the photovoltaic film down to where they can actually almost inkjet it onto material, but it only produces about a third as much juice. Now that's made to be flexible, and it will take indirect sunlight and actually utilize it. But when you're putting a solar array up, your main thing is, and this is the company that I work for didn't do it. A lot of companies these days will, because it's make the customer happy. But did you guys drive in past Wayne National Forest on the way down here? Did you see that big array on their roof? Third Sun did that array. Dovetail did not do that array because they're engineered. You know, all those panels are facing like 60 degrees off to where they have to be to actually produce the electricity they're made to produce. But you have the aesthetic quality. That building was not made for solar panels on that angle. You know, you can go out with your solar calendar. A lot of states, if you set up an array, that gives you precedence over your neighbor's trees. But when you go to do like your site assessment, your first thing you have to worry about is your electrical consumption. Then you have to worry about like the structures that you have to deal with. Other than grounding them out, that's the biggest issue, and that's probably like almost half your cost with getting an array is your permitting and your grounding out. DC will fry you. You know how it's kind of funny. DC runs one way, and AC goes back and forth, right? Thomas Edison actually loved DC electricity and didn't like Tesla's ideology of capitalizing on AC electricity, and actually used them doing the death chair, the electric death chair with AC. And he did that as a political move to try to make his DC power grids go up versus AC power grids. AC will travel along a long ways. Now DC, the thing is with it, will kill you like immediately. With AC, if you get locked into the shock, you can pull your hand back. DC just keeps flowing. It's always looking for a path. Yeah, so like every, nut, bolt, and everything is made, not to corrode and to be actually grounded, like into itself. But DC's utilized actually in everything. But to have electricity in your house and to reach over and hit your switch whenever you feel like hitting your switch, you have to do battery storage or grid tie. Now, for storing energy, I've seen people do micro hydro. They'll pump their water uphill, and then they'll use micro hydro, and they'll just let their tanks out and let it move down. You only need about 20 feet of fall for a micro hydro system to work, but you're still looking at losing about a third of your juice. So when I came down here, the state was giving people a third of their money back on an array. If you go ahead and spent 15 grand putting solar panels on your roof, you didn't have to pay the government $5 grand in taxes at the end of the year. Well, when they took that away, all the solar systems that people were going to buy 7 years of electricity, now they're looking at like 12 to 15 years of electricity up front. You know what I mean? So the residential install market dropped. But in states where they're giving good benefits to the consumer for you putting in a residential install, then it's doing a lot better. Part of the trend stayed like I thought it would. Like, I lived in a couple medical states before I came out here for school, and I thought anybody with a good indoor grow will be able to offset their electrical consumption from it. You know what I mean? Like after 3 or 4 years. And that's actually, from what I've seen being down here, with it doing real good in Maine and up north, and PA has a really good solar industry, and they haven't gone medical yet, but they've enacted the benefits and kept them there. So I'm kind of frazzled. So yeah, I had some Kool-Aid at like sunrise. So I was hoping my head would be straight enough to have a be able to share and have it be, you know, in a. So you look like you have questions about solar. You have property. Do you want to put some up? Okay. Yeah. 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 Well, if you see, if you have to design your home to accommodate your restrictions that you're dealing with getting, you know, 3, 5, maybe 8 hours to where it's pumping juice into your system, so you have your climate control that you have to worry about, and then your startups. Yeah. What you'll want to do is, um, you're going to want to look at what your energy consumption needs are for like all your major utilities and your climate control. A really nice built house can take like 1/20th of the electricity just to start with to have to deal with heating and cooling. You know, mine doesn't. I live in a barn. Like literally, like there's an apartment upstairs about the length of this, but I got like 80 acres outside, so it's kind of nice. But I've actually thought about putting panels up there, but it wouldn't work. Like you definitely have to look at where your trees are. You start off doing your site assessment with a solar calendar. I didn't bring one, but it's basically a globe, and it has the night sky, or you take a picture of it, it shows you the shading of everything. And then depending on the chart that you lay within it, tells you where's going to be shaded at what time of year during what time. And then from there you go in, you figure out your tilt. If you're going to have a higher need for electricity in the winter, then you're going to want it tilted lower towards or more up, because there's about, you know what, that 7 to 18 degree difference of where the sun's sitting in the sky during the day. So, oh yeah, yeah, and you can do now. Tracking arrays will produce like maybe a third more electricity, but then you're dealing with a bunch of moving parts that might fail. And that's the big thing about it is if your components are going to last you 25, 50 years, you know, you just want it sitting in one place to leave alone. Now, a big part of the cost I was saying was in racking. That's because they use aluminum mostly because of the roof mounts and stuff. Now, something that I've found out since I've been down here, and I helped one of my teachers put an array up next to his workshop. Now, if you're gonna put an array down, it's gonna hit your roof, or it has to be something on the ground that's not gonna move. Well, just putting in a big concrete slab is a couple grand, right? So, an alternative, no, and I think this should really be utilized, and I haven't seen it be utilized, but my one instructor did on his property, is you can get those 20 and 40-foot steel shipping containers, and those only cost like $1,000 to $1,500. Now you can literally, what my teacher did is he had two 40-footers, and he put an array up across both of them, and it's doing, he put like a 40,000, uh, he just tripped his first megawatt inside a year. But here's the kicker. Aluminum, all of our precious metals, copper and everything. I mean, copper is worth more than the penny that it's in now. So the aluminum racking, you're looking at spending a couple grand on that, and then you're looking at spending, thousands more on getting your concrete laid and whatnot. Now, if you actually mount on a shipping container, you can use steel. It's like 1/5 the cost to go get the channel. I mean, you have to design it all out. Everything's, panels usually only rack on like 4 places. Well, you can do that, or you can use them for storage space. What he does is he makes stands and tables. He has like this big electric lathe, and he uses it to power his shop. Well, he only works during the day. So he bought, the way he looked at it is, I bought, 7 years of my juice up front, but he already went through and became a panel wholesaler. So, like, if you want to go look into solar and you're like, okay, I can get 5 panels, 240 watts, that'll produce, 10,000 watts per hour of peak sun, that's not what you're getting. You have to get what it's attaching to, whether it be on your roof, on the ground. You have to have that pretty much. There's a lot of engineering that goes into like a roof, like how much weight can this board take, and what have you. So it won't blow off, but at the same time it can take, take the weather conditions. I mean, and the thing is once you get your racking in place, like I said, most buildings, the roof is not warranted as long as your solar array is. I mean, a roof will go, you'll get it redone. So if you get a solar array put on your roof, you have to take into consideration when is this getting refinished and how I'm going to access it. You have your own box area. Batteries are huge maintenance. They fail, but if you don't mind losing a 30-year juice, a battery bank really is good. I've seen it quite often. People add like tap water or whatnot, and not instead of purely distilled water. That'll fry the electrochemical reaction within a battery after a couple times. Well, there'll be minerals that'll attach with what's supposed to be be doing the current exchange, but it's very practical. But Japan, Germany beat us. Their banks, you could go in and say, I own a house. I'm putting this array on there. It's taking $70 a month off my electric bill. Give me a 10-year loan for it. The U.S. doesn't do that. I could build an array on your property, and you could sign a note saying you're buying the electricity from it. And the bank will give me a loan to put that array together and put it on your house. But you, as the homeowner, you have to have the money basically up front. So, like my former professor, he put it on a credit card. He found a bank card that would offset everything. Now, one of the main costs that you get back out of a solar array, they have what they call SRECs, carbon credits. It's when dirty energy producers have to offset their dirty energy consumption with having like 20 to 30% renewables, depending on what their precinct zones them for. So they have to buy these SRECs that you produce for producing electricity. Now, a couple years ago, they were going for like $400 a piece. So, and like one professor said, now that I produce 10 SRECs, well, they used to be worth $400 a piece. That means that he was actually going to get $4,000 back this year from what his solar array produced. But now commercially, they're only going for like $100 a piece.